Moving on to question 10 here, we have a differential equation question. So again, it's nothing too exciting. It's about passengers on a roller coaster, and it's modelled by this differential equation given here. And for part A, we have to show that h is equal to 5e to the 0.1 sine 0.25t. So the first part is quite tricky. The next parts aren't too bad after that, but part A is quite long. It's very easy to trip up with it. So let's have a look breaking this down step by step. So the first thing to note is that this is a differential equation, and we have to show that h is equal to this given expression. So that means we have to split the variables, right? Now, remember when we split the variables, we look at what the numerator is. Now I know a derivative isn't a fraction, but just imagine it is a fraction for the sake of these questions. And the numerator, the variable that we're, is the d with it, that's what we're getting on the left hand side. So because it's a h here, we're going to have the h on the left, and then similar, we'll have the t's on the right. So whatever's on the bottom goes on the right. So because we've got h cos 0.25t on this side here, we're going to have to divide by h. So that's going to give us, so we would divide both sides by h, 1 over h dh, like that. And then the right hand side is going to be cos 0.25t divided by 4 dt. So that's going to be cos 0.25t divided by 4. So what happens when we integrate both sides here now? So imagine we're integrating both of these, so let's do that. And if we integrate this side as well, what are we going to get? So 1 over h dh, well that's just going to be ln h. So remember this is the ln h derivative and integration. I'm losing my voice here on this question already. Cos 0.25t divided by 40. So if we're integrating this with respect to t, now remember you can factor out the 1 over 40 to the front of the integral. Or you can keep it as the denominator, it's absolutely fine. But what this is going to give you is sine, because this is cos 0.25t, and then we're going to divide by 10. So we're dividing by 10 now. And this is, because it's an integration, don't forget, we need our constant of integration like that, plus c. Now we know, given from the question here, that the passenger is 5 meters above the ground at the start of the ride. So what that's saying is that when t is 0, so these are our initial conditions, when t is 0, h is equal to 5. H is equal to 5. So all we're going to do now is just set this up as an equation. So ln of h, so ln of 5, is going to be equal to, well, if t is 0, it's going to be sine of 0, which is just nothing, so nothing divided by 10 is 0, plus c, so that's going to be equal to c. So therefore, c is equal to ln 5. So what we know now is that ln h is equal to sine of this expression here, 0.25t, and divided by 10 still. And then wherever we've got the plus c, we know it's ln 5. So this is going to be plus ln 5. Because we've already worked out that c is equal to ln 5. Now what we need to do is just simplify this using the rules of logs. So to simplify this now, we need to take this the ln 5 across to the ln h. So that's going to be ln h minus ln 5. And that's going to be equal to this. It's really monotonous writing all this up. Sine 0.25t divided by 10. Remember, we can simplify this here now. So we can write this as a quotient. So this is the same as ln h over 5 is equal to this. So sine 0.25t that's 0, 0.25t divided by 10. And now we can anti-log here. So because this is ln, we're going to raise everything to e. So this will just become h over 5. So this becomes over here, h over 5. And this is going to be equal now to e to the power of all of this. Now, they've given it as 0.1. It's the same as 1 over 10, but we'll write it in the form they've asked for. So it's going to be 0.1, e to 0.1 sine, and then 0.25t. And then finally, we're nearly there. We've got one more step. So this is divided by 5. We need h, so we just times 3 by 5. So therefore, h is equal to 5e 0.1 sine 0.25t. So that's part A done. We've got it into this expression that they've asked for. So let's just quickly rub this out, and then we can move on with part B and C. So parts B and C, they're only for 1 mark and 2 mark each, so they're pretty quick. Part B is asking us to state the maximum height of the passenger above the ground. So we've got to think about how we can set this up here. So it's just a 1 marker. Think about what happens with the maximum of sine and cos here, and what them values have to be. So for this one now, for B, so we'll quickly just carry on with B up here. So for B, well, the maximum, so we're in sine here now with this part here. Well, this can only occur when sine is equal to 1, sine of 1, right? So this is going to be 0.1 times 1. So what we have now is this equation, h is equal to 5e to the power of 0.1. And if you do this on your calculator, this is all you'd get in for this. This is just going to be the 1 marker. You'll get 5.53 meters. And that's part B done. And then finally for part C, let's read it. The passenger reaches the maximum height for the second time, t seconds after the start of the ride. And we have to find the value of t. Now you've got to think about where these maximums occur. Remember, the first maximum of sine occurs at pi over 2. The next one, so you just, it helps if you draw a sketch or if you just know it by heart anyway. The next one will be at 5 pi over 2. So 5 pi over 2. So 5 pi over 2. And it occurs, so we're looking at 0.25t. We're looking at when this is going to be equal to this. So we just set this up as an equation now. So c is equal to 0.25t is equal to 5 pi over 2. So we're just checking for the second maximum point of the sine graph here. And then we just solve this. So all we need to do here would be to times this by 4. So this would give you t. So if you times this by 4, you'd cancel part of the 4 with the 2 here. So you'd have 2 times 5 pi. So t would be equal to 10 pi. But as soon as it wants it as a value, if we actually give it as a number, this will be 31.4. Like that. And there we go, that's part C done, part B done, and part A. So the trickiest bit is part A, but as long as you can get through that, the rest of it follows quite nicely.